Hello, I'm Robert. Fact checking, helping with things that scare you, and welcome to my channel. And this time, it's a good news story, and this is an example of how, sadly, when you've got a good news story about climate change, then none of the journalists run it. Now, I can tell you, if this was a bad news story, it would be running around the world and it would be headlines. So this is about the headline here will be that as the earth gets warmer, then it gets easier for plants in deserts on average, and you get dry lands that stop being dry more than you get ones that go dry. That was quite a surprising result. So I'll just explain it a little bit here. So here you see the red lines. That is the conventional way of describing a desert, and the blue lines is using this new method. And the conventional way is just based on the amount of water vapor that evaporates from a warm layer just above the ground, and compared with the amount that goes into that layer and goes out of it. And then the new way of doing it is based on looking about how much water goes in and out of vegetation on the surface. And it turns out that if you look at the effect on vegetation is much more able to absorb water and not give it out than the just dry land. And so once you use this new index, it turns out, and this gets, so sorry, I didn't explain that quite right. What I mean is that as it gets warmer, then, so at the moment, these two indexes are just about the same. You can see the blue line more or less exactly follows the red line. The yellow areas here are rather obviously desert, and then these are the damper dry lands. Not all desert, but they're dry. And it's desert and kind of scrubby, dry bushland and things like that. It tends to be drier areas. Now, so if you look at the this new measure, it's just about the same at the moment. But now, if you go forward to the future, then what makes a big difference? This is the future, and the difference that you get with the old measure and the new measure when it is 4.9 degrees warmer at the end, towards the end of the century. If this is an impossible future scenario now, really, this is if we were to keep burning more and more carbon dioxide, more and more coal, 5 times as much coal in the year 2100 as we do now. Coal is the fossil fuel that produces most CO2 of all of them for the same amount of power. So this is obviously not going to happen because the coal use is going to be reducing, and in many countries it is already. And indeed we're not going to go anywhere near that. But even if it warmed as much as that, so this was the older way of looking at it, then as it got warmer, all these regions that are surrounded in red, these become dry lands where they weren't before. So those whole areas start getting drier. Now, if you look at it with the new way of looking at it, then all these blue areas, they get wetter. There aren't any blue areas there. Well, there's one little blue area there. See a little blue, outlined in blue line. Let's see, copy image location. I'll put that, I'll see if I can magnify that image a bit. There we are. I can maybe come in. So, if you look there, there's a little blue thing there, and a little blue one there, and a little blue one there. So there are a few, I think there was the only 3, there was a little blue one up there as well, which go from being dry to being wet, being not dry lands. And then the others, all huge area there that goes towards being a dry land. It isn't at the moment. And there, and there, and there. So that's what they used to think. And look, in the United States, quite a large area. Now, if you look at it with this new measure, so that is about if it was just land without any vegetation, and those areas they'd be much drier at 4.9 degrees than they are now. But now, if you look at the effect on vegetation, then many of these areas, they actually get wetter. Look, there's a whole lot of, see, that's actually almost in the same place as that bit. We've got a whole lot of blue ones that are actually getting wetter for the vegetation. That's because as it gets warmer, the extra CO2 in the atmosphere means that plants can have smaller pores, and so they don't let out as much moisture. And taking that into account, then they find that as the world warms up, and then just looking in detail at what happens to the vegetation, then vegetation actually loses less water, and then the atmosphere is actually moister quite often in a warmer world. And so it's actually losing less water, and it's still a moisture atmosphere. Then you end up with these areas that are actually getting wetter as regards the kind of dampness that the vegetation feels, rather than the dampness that the land feels. Basically, it's a difference between what a vegetation feels and what dry land feels. And so at 4.9 degrees centigrade, the vegetation will feel that it's damper, but the dry land will feel that it's drier. And so this means it's really a big difference. So this is a drylands contraction, because those are all areas that are no longer drylands. It's a drylands expansion which become drylands. So it's not there still are areas that get drier, but remember, this is a very, very much warmer. We're never going to get anywhere near this level. So this is really very positive news. Now imagine that if it had been the other way around, and they had looked at it, they found that these dry areas actually get twice the size, say. Then this would be on the headline in BBC News, on the TV. It would be running in New York Times, Washington Post. Everyone would be running that story, that in a warmer world, the drylands will be much more extensive than people used to think. But this news story, that actually the drylands are going to be much less extensive, and some of them are just going to go away from what they are today. Nobody's running it. Now, you might wonder, oh, but is this a reliable source? I got this from Carbon Brief. And this is close. Look, I've got a little zoom in on Mexico, because some people are from Mexico. So look at that. And then you've got Florida as well. And then look at that. You've got a little, is that Texas? I'm not sure. You've got a little damp area in Texas where it's dry, according to the previous way of thinking about it. There is a dry area there, but most of it is getting actually less dry land. And so these are going to areas that used to be very dry desert, or just is dry land, or like scrubland with not very much vegetation and a lot of sand and just a few plants. And then they're going to turn to something much more vegetated in this, if we did go as far as this much warmer world. And this only for a huge amount of warming. So this, have I got a link to the Carbon Brief? I must have somewhere. Oh, I do seem to have forgotten to add the link. So I will. Oh yes, here we are. There, I haven't forgotten. So that's the actual story. So Carbon Brief. They are the only really big site that I recommend. That's they run stories about just about everything, and they are very high quality. The only problem is that they are more a site for geeks, because they are rather techy, and they don't use it's well written articles, nicely written, but they have lots and lots of graphs and things like that. Where's this? So there we are. So what a dry land. Sure, I mean, it's not that techy. I mean, it'll talk like, say, metrics, for instance, and that's the aridity index, which is what it's usually called, and then the new measure is the new study. What does that stand for again? The EI. So it'll explain that somewhere. Alternatively, properties such as the response of plants to rising CO2 levels. Yes, they define AI first. Yes, the eco-hydrological index, which represents vegetation amounts and water stress levels. It captures links between the plant behaviour and atmospheric CO2 levels. And then these are various experts, saying that this is an improvement. So Carbon Brief talks directly to experts, and it's experts talking to experts. They're talking about really good science researchers, science journalists here. They're really excellent. They do it properly. If only we had real science experts, science journalists like that, writing for, say, the BBC News. They have their science journalists, but maybe they don't have enough time, I don't know. And maybe it's because they've got to make clickbait stories, and so they have to invent stuff. I don't know why, but they have had appallingly bad journalism with the BBC for the last 2 years. Absolutely appalling. And the only on climate change. And I think the only big outlet that I recommend is Carbon Brief, which very few people have heard about. So total area doesn't change much. So this is if you do it this new method. The drylands expand or contract in various regions, in particular based on precipitation changes. The total area doesn't change much. Basically, you've got more or less the same amount of rain. You've got a bit more maybe, and then the land is warmer, but the vegetation doesn't seem to mind that. And so, as it gets warmer, the vegetation is able to still make do with the same amount of water as before. And so, whereas the land, if you haven't got vegetation, gets drier. And so that's why they haven't managed to. That's why it's made such a big difference. And so based on two things. First, the leaf area. So there we are. Here's the actual definition. The leaf area index, which is a measure of the amount of vegetation density. So this is a discovery that is already happening, that as the CO2 levels increase, leaves get larger, and also trees grow much faster. It's been great news for forestry and also for crops. And through to 1.5 degrees C, then we're going to have more crops, much easier to grow crops for most types of crops, especially apart from maize, because that already does very well. Maize is a C4 crop, and that is like pineapples. It's able to do very well with very low levels of CO2. Indeed, you could go down to much less, even almost no CO2 at all in the atmosphere, and a C4 plant will still be able to use it well below anything that's ever been historically. And maize won't notice. But rice and wheat and most of these other crops, they are C3 plants, and the more CO2 there is in the atmosphere, the better they work. Indeed, there's this idea of developing a C4 version of rice, and if we ever do achieve that, that's a huge project that is underway. Lots of people working on it, but it'll probably take at least a decade if we do achieve it at all. It's very difficult to move it across from maize to rice, because it's lots of different details of how the maize plant works that have to be copied over. The actual structure of the plant, structure of the leaves, has to be changed, not just the way that the photosynthesis happens. And so people are trying to work on that. They have to move lots and lots of genes from maize through to rice. And it's a very, very complicated. If it is achieved, it'll be one of the probably the most complex genetic engineering that has ever been done. But they're trying to do that, to get rice to work like maize. And then that will hugely increase the rice yields and let them work at warmer temperatures and drier climate. But they haven't done that yet. But short of that, then the warming does work for rice, as long as they can keep it damp, and so long as they keep developing new varieties of rice that are able to withstand warmer temperatures for the very warmest areas of China. And so far they've been keeping up, and they're continuing to keep up. So as a result, the rice yields are actually increasing with warmer temperatures. Wheat, it doesn't have that same problem of it getting too warm for it, and wheat yields, they're going up. And generally, most C3 plants, their yields are still going up. So this leaf area index is related to that. It's the same idea, that because you've got more carbon dioxide, it's called the carbon dioxide fertilization effect, although it isn't really a kind of fertilizer, but it works a bit like a fertilizer. And so that's one of the things that it's taking account of. The other is plant transpiration, and that's to do with how much moisture the plant gives off. And as it gets warmer with more CO2, the plant is able to manage with less. It can manage to still do its photosynthesis with giving off less water. And so, and it's the relationship between the surface soil. So that second number is the relationship between the soil moisture and the amount of transpiration. It's a relationship between those two things. So when that number is negative, it means the water is leaving the soil faster than it's being replaced, and the plant growth is limited by the water available. When the second number is positive, then the water is leaving the soil more slowly than it's replaced. And so you've got the two things, leaf area index and that, the combination of them two together, and that gives this whether it's actually getting easier for plants or more difficult as it gets warmer. So that's a new index. And he's saying that the AI one probably won't continue to work. It's worked, the AI one, the old one, has worked very well so far, but he thinks it probably won't hold up under conditions of warming and with more CO2. And several other experts here, they're all saying the same thing. Really nicely done study. I strongly agree with the authors. And this one is saying that he speculates the EI is a more fundamental, it's a better index, but they may need something a bit more complicated. It's a simplification of a very complex concept, and still bears the danger of missing out on important issues. So that is an important caveat. But and the high level of uncertainty in simulating land on a global scale as well. But he says, but Berg is saying it's better to embrace these uncertainties than rely on a flawed atmospheric approximation. And they're still working to improve land models and reduce these uncertainties. So basically, the basic thing you get from that, you can see from that, carbon brief is a little bit more technical, it's a little bit more intellectual. You've got to think through and figure out, like I was thinking it out as I was talking to you, you've got to think about, and for instance, about the leaf area index, what I explained to you about the crops having higher yields with higher CO2, and the plants, that their leaves are getting larger and trees are growing faster and all that, then they write this, they expect their audience to know these things. So they don't explain all this. And a journalist writing for the BBC, if someone for the BBC was to read this carbon brief article and then rewrite it for the BBC, which would be an excellent thing to do, they would have to explain those things that I just explained to you. So that is the sense in which carbon brief is not just it uses technical language, it also assumes that you have been following the climate change literature and are reasonably well up on things like understanding what all the contexts, when you mention something like leaf index or plant transpiration, and how CO2 levels increasing reduce plant transpiration. They assume that you know all that. And so if you've been like me, I am not an expert on climate, I'm just someone with a general interest. I've got a good scientific background, I've been following it since the subject began, basically. And so anyone who's been following it, you don't have to be an expert on it, you just have to be a scientist with a good background in science. Then you will understand all these things, as long as you've been following the topic for a few years. If you've just never read anything on climate change of any technical nature, then you are likely to be baffled by these things as well. Not really, you will understand the basic points, but you will be missing an awful lot of the nuances and contexts if you haven't been following the subject. So that's why I'm a little bit hesitant about recommending Carbon Brief, because sometimes those nuances are important. Sometimes you may read the article and then get the wrong idea at the end of it as well. It can even be like that, because you're missing some of the context of why they wrote that article and what it means. But even so, slight risk of that compared with the sort of misunderstandings you'll get from reading the BBC if they were to write an article on this. Then so I still think your Carbon Brief is the best of them all. I don't know, I'm sorry, I just don't know of any good site to recommend that hasn't got a kind of axe to grind. It isn't either sort of activist or is trying to prove that global warming doesn't exist or something like that, or it's journalists with clickbait titles. I don't recommend the Scientific American or New Scientist, really. They don't do accurate climate change articles anymore. Very sad to say that. You used to think, oh, if it's in Scientific American, it's absolutely fine. The part of the problem is that Scientific American and Nature as well, they do this thing of syndicating articles that they didn't write themselves, and these are often very bad. They can be as bad as the journalist ones, and yet but in more techy way of writing. So the only, even including the general public scientific literature, then the only one I really recommend is Carbon Brief. They do it properly. Of course, there are lots of blogs by experts, and if you go and look at the people who actually wrote the study. And then the other good thing is if you go to Twitter, but watch out, because you get activist scientists on Twitter who know that what they're saying isn't really true. Again, sorry to say that. So they go around and they claim to be just presenting the science to general public, but they've actually put a huge activist slant on it, and they actually even just lie, out and out lie. So I won't name any names here. I have named in the past, but no, but just to say there are a few like that. So, but if you go to these people, the people who they interviewed here, most researchers, if you go to their private Twitter account, then they'll be giving very decent kind of. It's really the flashy ones that you see that are always in the news, and saying very dramatic and bleak things about climate. And sadly, some of the actual climate scientists have taken to just exaggerating everything. I think they're trying to make people act by just basically, but then what they say isn't true. And I think absolutely, when you talk to the public, you should tell the truth. And this actually is more effective for activism as well. Anyway, so that is another thing that you can do if you go to especially if you've got a little bit of a good scientific background I'm talking about now. Then try going to the actual scientists themselves, your ordinary everyday workaday scientist, and what he says about his research, talking about it as well as he can, or she can. Sorry, don't want to be sexist, but say whatever she can or he can about their science, talking about it to the general public. They tend to be very good as well, but they tend to be a little bit techy sometimes. Some of them aren't. Some of them are very good at expressing what they say to the general public as well. So that's another source that I use a lot. Following the actual scientists on Twitter Twitter has turned out to be an excellent way because they put it in very concise ways. And then now, especially now, you've got multi-thread tweets. So I use Twitter a lot nowadays for keeping up with climate science. And then, I mean, this particular one, it was someone shared it on our Doomsday Debug group on Facebook. Our Doomsday Debug group on Facebook has turned out to be quite a good way to keep up with things like this, because we get quite a few people come there who are quite they're knowledgeable. Some they tell and they explain these things to other people in the group, and they share these research with people who, like me, are able to read Carbon Brief and understand it, and then share it and understand the basics of what this is saying. And anyway, so I'll upload this, and hopefully this sort of put a bit of a smile on some of your faces. That good things are actually happening, and it's not always as dire as people make it out to be. It's actually hugely positive what's going on. We've got an awful lot to go do, but we've got sometimes things break our way. They're not always breaking the other way. We've got quite a few things that have broken in our direction here. This is breaking in our direction, the response of vegetation to warming. That's a positive thing on our side. And there are quite a few things like that. So, sometimes it goes the other way, and then we get these periodic reports every the next one in 2022, the next big summary of all climate change literature, the IPCC summary. Then you generally find with each one that you've got some positives, you've got some negatives, and they end up almost exactly the same projection as before. But we are getting hugely many, loads and loads of journalist stories about anything that seems even remotely going to push it in its worst, and we just get almost nothing about these things. But the IPCC, when they do their big survey, they look at everything. So they will look at these things. And so it's really only with the next one in 2022 we'll get a proper overview of the whole thing again. And I expect it to be pretty much the same projection as 2018, 2019 for the ones that were in 2019. Because these things, they tend to cancel each other out. Just natural tendency. You've got half a dozen different things, and you've got them very slight refinement, and some will refine one way, some will refine the other way. On average, they tend to cancel each other out, and you end up with pretty much the same projection as before. And that's another very interesting one in Carbon Brief, that they looked at projections using climate models from the 1970s, 80s, 90s, and they all made the same prediction pretty much to the future. And then if you fed into them the actual CO2 emissions from human beings that actually happened over that time, because they had to model that, then they all came pretty much exactly to the same prediction for today. So it actually works, despite all these things about all these things, it actually works pretty well. Even when you've got very crude models, the things they leave out tend to cancel each other out. So it's always been like that. So that adds to the it's not the things that I don't mean that they deliberately leave them out, but they know that they're approximate, and they try to give an approximate limitation of the rest. So I'll talk about it another time, but basically the IPCC don't leave anything out. They do a survey of the entire scientific literature at the time of the survey. The models leave things out, but the systematic review of the IPCC leave nothing out. But they will sometimes say, so the previous really big one, they were not able to model the melting of ice. They said, none of our models are able to model ice properly. So we can't predict the rise of sea level. That's what they said. We now know how to do that. But back then they didn't. So the models just weren't, it was just too much computer power, too difficult, too many things that they weren't able to do yet. And so, and they just didn't have the data yet as well. We now have a lot more data about the ice melt processes, even things like underneath glaciers and things. And we have much better computers. And so back then, what the IPCC did is they said, in this study, in this big review, we are not able to say what the sea level rise will be, and we can't even do a very good limit on it. I mean, obviously not all the ice in Greenland going to melt, not all the ice in Antarctica going to melt, but they didn't know, they weren't able to do it, to even give proper error margins for the amount of the sea level rise. So they just said, we'll just model based on the warming of the sea and the things we can model, and then you've got to allow for it. There could be quite a lot of addition on that. So they actually said that in the report. So that's how they deal with these things. And with the most recent reports, there's very little left out now that is going to make a significant difference. In fact, there's nothing left out that's going to make a really big, significant difference, according to the best understanding of the science at the time. So they looked at the methane emissions of the melting of the permafrost, very hard to model. And they don't even, the difficulty there, then the melting of the Arctic sea ice. So some issues with that. And then then the melting of the permafrost, what's going to happen? This is a problem of what's going to happen to the microbes, what they're going to do, what particular microbes are going to grow there as the permafrost melts. And so that's very difficult to know the answer to that. And depending on what happens and what vegetation grows and so on, you can even get a net sink, or you can get an increase of the amount of CO2. So they, in the last one, they just looked at that, and they said that was the 2019 one, the most recent one that looked at that problem. They said, we don't know, we can't say whether it's an increase or a decrease, but we can limit it, it's less than this. So, and it's not in the models yet. It's in very few of the models. But we know it's less than that, based on our best understanding. So that's how the IPCC deal with things like that. Anyway, so I'll now upload this, and yeah, hope that helps some of you. So just a shout out for our group, Doomsday Debunked, on Facebook. If you are scared of things like this, also if you're an expert or you are good at reading the scientific literature to help people who are scared and to explain things to them. Many of our members have no scientific background, and sometimes just very simple things, very, very basic things that a scientist learns. Someone with a scientific background might well learn them as primary school, some of these things, if you're very keen with it. But many adults, of course, don't have that level of science, of what a very keen scientific kid, would know in grade 10 or 11. But then many adults, just like if you're very good at language, you could be very good, you could speak half a dozen different languages at age 10 or 11. Whereas other people, they just don't, I can't speak any language except English. So it's the same with science. So if you're a science geek, then you can basically speak half a dozen different scientific formula type language things when you're age 10 or 11. And many adults, they still just don't have even the basic ideas of anything, except the way that they think about things. But it isn't really very scientific. So you can help if you've got a good scientific background, then you can really help people in our group with sometimes very basic answers to things. And then if you're scared of things like this, or if you need to just hear some positive news as well. But slight warning that our Doomsday Debunk group, by the nature of it, we get lots of stories being shared, sometimes very scary. So, but then there'll be stories you see in the media anyway, some of them anyway, and then you get someone come along and explain it, So you get that gap. Usually it's not very long, usually it's a few hours to maybe a day or something. But you do have that gap because depending on who's online at the time and when they've got time to answer and do the research before you get an answer. Anyway, but yes, so you're very, very welcome to our group, and then do like and subscribe this channel as well if you find it helpful.